Okay, our next presentation is going to be a tag team done by Seth Burgess from the Connecticut DOT and Mike from Transpo, Mike Stenko. So with that, they did again, it seems like we like doing trusses on our deck work. So, gentlemen.
Good afternoon. My name's Seth Burgess, engineer, as Rich stated, from Connecticut Department of Transportation. This is Mr. Mike Stanko, a representative from Transpo Industries out of New Rochelle, New York. This project is similar to what Steve just presented, but happens to be quite a bit downstream. I was asked by Rich, who is also the chair, to show the importance of the interaction between states, consultants, and vendors to determine the proper fix for site-specific needs. I got a chance to meet Mr. Mike Stanko last year at the 2014 National Conference in Orlando, where their material was being displayed. After review of the site's conditions, Mr. Van Al and I determined that their product would be the best fit for the needs at hand. The bridge, number 1138 East Haddam Swing Bridge, crosses the Connecticut River between the towns of Haddam and East Haddam, Connecticut. Carries Route 82. In 2012, the ADTs showed that more than 10,700 vehicles traverse this bridge daily. The current bridge opens for local recreational vessels, minor industrial, the occasional barges, and Coast Guard vessels as needed. The busiest times of the years are spring and fall months, where on a typical weekend you can have 10 to 15 openings per day. During the summer weekends, you can have approximately 5 on a Saturday or Sunday. The importance of this bridge is that the closest alternative crossings are either 20 miles north between Portland and Middletown, Connecticut, the Aragoni Bridge, Route 66. Your alternative is to take a ferry that's approximately 5 miles south or continue 15 miles south to the Baldwin Bridge between Old Saybrook and Old Lyme, Connecticut, which carries I-95. Fortunately, I was able to obtain some of the original construction photos of this project. Give a brief history of it. The engineer responsible for the design was Mr. Alfred Baller. At the time, he was one of America's most well-known engineers and was considered the nation's leading authority in deep foundation engineering. Baller designed several hundred and complex bridges, including several large New York City drawbridges, as well as the 1889 railroad bridge crossing the Thames River in New London, Connecticut. Unfortunately, Baller did not get to see the completion of the bridge. Construction was completed prior to opening to traffic on Flag Day, June 14, 1913. The duration of the project was approximately 2 years. It was hailed as the embodiment of the age of progressiveness. It consists of a 461-foot through truss swing span, a 327-foot Pennsylvania truss span, and a 101-foot long fixed deck truss. The 461-foot swing span is one of the largest of the world and of its kind to date. The structure contains about 1,300 tons of structural steel, 715 of which are accounted for in the swing span alone. There have been multiple rehab projects on this bridge throughout the years, including one in 1987, 1999, and 2007. This bridge requires constant maintenance, due to the extensive use, including weekly greasing, mechanical electrical upkeep, as well as the occasional structural steel repairs. Similar to Steve's issue, the way the bridge was constructed, they had laid an overpour material probably to try to protect the concrete filled grid deck. And as you can see here, quite a bit of spalling and popping was occurring. Due to this, it was creating leakage through the grid deck that has been exposing our mechanical components to the corrosive chlorides. This picture here shows the center span underneath the area shown in the previous slide. If you look in the back of the picture, that's the center pivot, which when the bridge is open, transfers the majority of the load to the center here. The 2 balancing wheels shown there rotate as the structure moves, and just behind those, there are load-bearing wedges that when the bridge is pulled, it's basically floating. I tried to get a panoramic view of the actual mechanical room that's down there. The picture in the previous one was taken just to the right. If you look to the left, there's two Philadelphia drive motors. One's shown on the left, one's directly across from it. As that turns a small gear, it rotates the bridge along the massive pier. Obviously the picture's distorted, but it is a perfect circle. This picture shows the typical condition of the east and west ends of the structure. Same assembly, same setup as the center. As the wedges are pulled, that center pin is raised, and that typically guides and centers the structure as it's closed. Works simultaneously with the center mechanical components. This is the issue that we have. That's one of the Philadelphia drive motors. Above it, you can see the condition of the stay-in-place forms. The chlorides have been leaking through the grid deck, deteriorating and exposing our mechanical components to these chlorides. We'll begin to get into the preparation. As you can see, the east and west end has a small portion which needed to be addressed above the wedges that I had previously shown. To do so, we used spade bits and chipped off the actual overpoured materials to try to get as most of an even surface as possible for the application, while eliminating any future popping that could occur. Other preparation that was required, as mentioned, we removed all the overpours. We repaired certain sections that were deteriorated and completely spalled by filling with, we utilized rapid set as it was, we were trying to get in and out of the traffic's way. We welded some of the grid deck seams, tried to increase the rigidity between the grid decks, especially over the center pier where there's a lot less movement, in hopes that it wouldn't affect the overlay in which we were applying. We also, as you can see here, we had a couple of these joints that were previously filled with an epoxy material. We removed that material and cleaned up the sections, and after discussing with Mike, determined that it would be appropriate to take the chip seal epoxy that we're utilizing and mix it with the actual overlay so we get a uniform material to fill these joints, which, as stated in the last section there, we filled it with the mixture of the aggregate and the chip seal. I'd like to give Mike a second here to discuss the material that we utilized for the sealant.
Okay, what we did, the first treatment or the first attempt was to fill the cracks in the between the grid deck and the concrete fill. And what we used is a high molecular weight methacrylate. A brief description, these are very low viscosity materials, slightly greater than water. They actually have a ability to flow deeper into cracks than water because of the chemistry that's built into the products. And the hope was to get this material to go down, seal between the grid and the filled concrete and any cracks that might be in the filled concrete, so we could come back and do an overlay material afterwards. Oh, sorry, I didn't realize I had another slide. Again, there were two different products that were considered. Both of these are high molecular weight methacrylates. There's a material that has an elongation of 3 to 5%, and then another material with a elongation greater than 30%. We felt that probably the greater elongation would be more important for this bridge since there was potential for movement. These are slow curing materials, around 4 to 6 hours cure time. They're 3 component materials. It's a resin with an initiator and a promoter. They're poured onto the deck. They feed via gravity into the cracks, and they have very high bond strength. The bond strength of the material to concrete is actually greater than the tensile strength of concrete, so virtually eliminating that crack after you've filled it with high molecular weight methacrylate resin.
The following slides will show the application of the sealant and prep work utilized for the epoxy itself. Typically, a crew of approximately 4 was utilized to mix and apply the sealant material following initial cleaning with dry compressed air. This picture here shows one of our employees spreading the material while the other gentleman is ready to utilize the broom to spread the material. We found that the broom method, in our case, was much more suitable, as if you use a squeegee, the deck had very uneven surfaces and you couldn't pull the material and spread it out evenly. Utilizing the brush method, we were able to scatter the aggregate or scatter the sealant and prevent excess pooling. Following spreading the sealant, we gave the material a couple hours to cure, as the day that we were out there was quite warm. It was a little over 80 degrees, so we had temperatures a little bit greater than what was shown in Mike's slide. Following that, a couple hours after, we applied 100% moisture-free silica sand for skid resistance. Due to the impacts on traffic, the availabilities of our crews, and awaiting ideal weather conditions, 2 weeks following the application of the sealant, we hired a low-bid shot blast vendor to come in and prep the deck for the chip seal overlay. The shot blast was conducted the same day the chip seal was applied to avoid any introduction of any contaminants to the grid deck from vehicular traffic. The operation went quite quick. He was able to go from one end to the center and to the other end in approximately an hour and a half. The steel grid itself was brought to near white conditions, and any loose concrete had been removed by the vacuum shot blast. Following this, the deck was swept and blown clean. I'd like to hand it off to Mike again to discuss this T48 chip seal material.
Well, this is a little different than the previous presentation we saw. This is a overlay, basically build up in layers of resin and aggregate. So you can build it approximately 3/16 of an inch at a time. And what we discussed and it was decided to do here is do 2 applications of material to build up to about a 3/8 of an inch thickness in these areas. So what Seth and his crews did is they mixed the polysulfide epoxy resin, which I'll give you some properties here. Again, very good bond strength to concrete, 250 psi or greater. Elongation, a 45% minimum elongation, so it's a very flexible material. And skid resistance is a function of the aggregate that you use to broadcast. What they did is they spread the resin, which Seth will show you in a second, applied the aggregate, waited for it to cure, and then repeated that process till the final thickness was achieved.
Following that shot blasting that was shown, our state crews utilized squeegees to evenly distribute the 2-part epoxy. Started with the brush on this, but brushes ended up absorbing some of the material and it was very difficult to spread. Care was taken to prevent too much material application and try to meet the manufacturer's recommendation on thickness as much as possible and to confine only to the fill grid deck sections. The application occurred over a 2-day process. First was the south side of the structure, which is in the eastbound direction, and the second is on the north side, shown here, heading in the westbound direction. Following the epoxy application, aggregate purchased through Transpo was scattered, and the purpose is to induce a skid-resistant wearing surface. In order to achieve a consistent and even application, our resin expert chicken feeder, Mr. Pete Nickerson, scattered with a firm flick of the wrist method, shown in the picture here. Approximately 3 hours following the install, the excess aggregate that did not bond tightly was removed and opened to traffic. The final product provides both functionality and is visually appealing, as shown here. This is the west end of the structure. Picture showing the final center span, which we did. One of the pros of this product for us was that you can go back in and address specific areas. We went a little bit light on the first day as we didn't want to run out of material, and due to wheel path and traffic, we ended up going back and applying a second coat in that section, specifically just because we didn't get enough material down. The total cost, not including state labor, was less than $20,000. That included the shot blast vendor and all the materials purchased for the application of the sealant and the chip seal epoxy. The original intent was achieved and hopefully prolongs the life of this historic bridge. Any questions? Steve took the majority of them for us, so that's a plus.
How many square feet did you actually do?
About 1,000 square feet. It was about 1,000, just under. So fortunately, it was a small amount, but as stated, we had to deal with traffic, which made it a little bit more difficult for us. And the prep work we did over about a 1.5-month period between removing the scale, removing any of the poor concrete, we were able, with the availability of our maintenance crews, fit it in based on weather. And fortunately, we didn't have any bridge openings the days that we were doing it as well, because we would have to pull all the material and all the equipment off the structure. So that was definitely a pro.
My question is, do you think that the shot blasting of the bridge deck was a good indication of the soundness of each piece of concrete that was inside the grid?
I'll say, fortunately, the maintenance crews we had out there spent a lot of time and effort when they were prepping it. The shot blast, we didn't notice any major spalling, any popping. Like I said, it mainly brought the rust off of the grid deck, and we didn't see any major issues with the existing concrete in the grid deck. And if there was any that happened to pop up, we utilized the material, the overlay, the chip seal, to fill those, to flood those. But we didn't notice any major spalling that occurred. If anything, it was just isolated and random.
When was the overlay put down?
The overlay was about a month ago. So we put the material down about a month ago, and the previous picture here was taken approximately 3 weeks after. So this has had traffic on it for 3 weeks.
What was the manufacturer's recommendation for PPE for the people that want to store home material?
Excuse me.
The recommendation is to wear some type of clothing to prevent getting spills on you. These are non-toxic chemicals. What do you mean? There's not vapors coming off of them. The epoxy is 100% solids epoxy, and the high molecular weight methacrylate, again, is 100% solids epoxy. So the care really should be taken in the mixing of the material, the mixing station, to make sure that there's no chance of getting it on your skin or breathing it or getting it in your eyes.
So during application, no PPE was needed?
We had gloves, we had glasses. The guys did get quite a bit on their clothes, and they did not utilize those clothes the next day. They ended up becoming trash throwaways. But in the pictures, they should have their gloves, their glasses, and obviously hard hats and safety shoes. Any other questions? I just want to say a quick thanks. Luckily this year, Connecticut was able to bring some of our general supervisors for our maintenance garages. These 3 gentlemen in the back, Scott Tebow, Alan Ferentz, and Mr. Eric Belanger, are in charge of running these crews on a daily operation. And if it wasn't for them, a lot of the work that we get done in our state would not occur. So I just want to take a quick thanks to those 3 for doing the work that they do for us.